Hello guys and welcome to our world's first 16K resolution gameplay rendered on a laptop, which is 133 megapixels, rendered on a laptop that is equipped with the GTX 1070 Pascal GPU architecture video card and Core i7 7th generation 7700 HQ CPU. Today, I'm going to show you two games rendered 16K resolution. This is going to be the first YouTube video ever posted on YouTube, 16K resolution on a laptop. And I'm going to show you Quake II, Yamachi Quake II mode, which is the fastest OpenGL render API, OpenGL 3.2 API render before the NVIDIA released the Quake II RTX that has also OpenGL render API ability, and that OpenGL render in NVIDIA Quake II RTX mode is the fastest ever OpenGL render that I saw in any game. Not only at 16K resolution, of course, not only at the Quake II, but at any game. Okay, so as you can see on the wallpaper, I also put for you some data from the much faster desktop PC, which is my beautiful Mozilla PC version 3.0, and it's going to be pretty much i9 9900K overclock at 5.3 gigahertz per core, but 2 cores was disabled and hyper threading technology was disabled, so I was running only 6 cores. Keep that in mind. And RTX 2080 Ti at stock. So we can compare, while I'm going to run some Yamachi Quake II mode, we can compare my data with this data on the wallpaper to get some delta, okay? Some performance digits, and for your analytics and analyzation. Over here, the CPU Z is in real time. This is the CPU Z from my CPU from the laptop, GPU Z from the laptop GTX 1070 video card, and MS Afterburner will be stuck. There is no overclock, even if you can. And this is the Asus 64 GPU benchmark, where we can see how fast the GPU in Asus 64 benchmark versus the CPU 7700 HQ. Okay. Let's go ahead, guys, and get going. Before, I want to let you know that this GTX 1070 video card in this Asus GL702VS laptop is the fastest GTX 1070, and it's going to be faster than GTX 1070 in a desktop. Why? Keep your attention. CUDA cores 2048 right here, and keep your attention over here as well. ROP 64, TMU units 128. Let's go ahead and pull up the data and check out the data out of the GTX 1070 desktop version video card. Okay, right here, guys. The desktop version has 1920 CUDA cores versus 248 that we have in our laptop GTX 1070. So we more 128 CUDA cores more. So it's going to be faster, maybe 1 or 2 FPS faster. TMU units 120 over here. In the desktop version, we have 128. 8 more TMU units, okay? Everything else the same. GDDR5, 8 GB of VRAM, and the same frequency on the GPU. All right? So let's go ahead and get going, guys, I guess, right? Let me close this out. I also put for you the quad-core 8 threads CPU utilization right here, so you can see how well it's utilized. And we're going to go ahead and start with Quake II Yamachi mode. But before that, let me show you that my desktop today is running 8K resolution 30 Hz with DSR up to 16K resolution 30 Hz. Because the laptop has HDMI 2.0B port that supports 8K resolution at 30 Hz maximum. Okay, as you can see, I connected to the external 8K resolution 30 Hz screen. Gigantic, by the way. 15,360 pixels by 8,640 pixels. 133 megapixels. It's rendered in real time, no joke. And then it's going to downscale this pixels to the 8K resolution. And 16K resolution downscale to 8K resolution, much better than just 8K resolution, guys. You can see the difference. If you ever try 4K resolution to 8K resolution DSR, you saw the difference. So you can see the difference right now as well. To 8K resolution native to DSR to 16K resolution. Much better visuals, everything is beautiful. So let's go ahead and get going. Yamachi Quake II Okay. It says it's set to OpenGL 3.2 API version at custom resolution. AF will be 16 times, multi-sampling, which is AA, anti-aliasing will be off. So what is the custom? Custom resolution, easy. Let me go ahead and show it to you guys. In the console, we're going to write our custom width. Make sure everything is lowercase. Enter. We're going to see that we have value of 3840 pixels, and our custom height, we're going to have 2160 pixels. This was my last test when I was testing for myself before I decided to record this video and share the data with you. So don't forget to smash that like button. You can see it, right? So what we're gonna do now, we're going to change the height to, let's start with 16K resolution. So what we're gonna do, we're going to go ahead and do 8640 pixels, and our custom width, we're going to do 15,360 pixels. Okay, should be our custom width 15,360. Everything should be lowercase. Here we go. And now we're going to go ahead and use the command width / restart. But before that, also in the menu, we gotta use keep the resolution. So it's going to pull the custom resolution. And I believe right now we set to 16K resolution. You can see how scaled the guy over there. Let me real quick go ahead and pull up the MS Afterburner information system server and make the font size larger. But you already saw, guys, you saw how small it was. So I'm not going to edit this video. I'm coming in real time. Okay, we are here. Okay, so now what I'm gonna do, I'm going to lowercase time demo space 1. So it's going to unlock the maximum FPS and it's going to render everything and show us the average FPS. And then I'm going to use the demo map command space benchmark. Benchmark is going to be the name of my demo file that I'm going to include in the video description for you to download. And you gotta use .dm2, very important. Here we go. Guys, keep your eye at the right top. GPU usage 97%, excellent or very good GPU usage. CPU usage below 25%, as you can see right now, 18%. Then keep your eye on the VRAM usage, which is 6,767 megabytes. Total allowed 8,000 megabytes, which is 8 gigabytes per our GTX 1070 video card today. And it's inside of the laptop. It's not the external video card, guys. This is on the Asus GL702 laptop that I purchased in 2017. So the system RAM is allowed today on this laptop 12,000 megabytes. Right now is usage 5806 megabytes. Okay, as you can see, it's not thermal throttling itself because the fan rotation running at 100% today. You're running 100%. Okay, we're done. I think around 68 maybe FPS, 70 FPS average, we're going to find out. 79.5 FPS average. This is 16K resolution. Yamaha Quake II version 7.21. Running in 2018, guys, on a GTX 1070 video card in a laptop. Amazing. 62 seconds to perform the benchmark. 4,931 frames. Okay, good. Now what we're gonna do, now we're going to change the custom width and custom height. So custom width, we're going to say 8,640. Actually, no, we're going to say 7,680. And custom height, we're going to say 4320. So this is going to be 8K resolution, 16 divided by 9 aspect ratio. We saw 16K resolution, 16 divided by 9 aspect ratio. Now 8K resolution, 16 divided by 9 aspect ratio. Now we're going to use width lowercase width underscore restart. Enter. It's going to reboot it, and it's going to show us that 8K resolution is quarter of our 16K resolution. Completely makes sense. How to fix to make it full screen. We want to make that we see it on a full screen. Keep resolution, switch resolution. Click apply. It's done. Okay, let's go ahead and execute it, and let's go ahead and have a look, shall we? Okay, I'm going to execute the benchmark. Here we go. Because again, you want to keep your eye at the right top. Above 200 FPS average. Wow, the milliseconds delay in each frame render is below 5 milliseconds. This is amazing. But keep in mind that Yamaha Quake II mode was the fastest OpenGL under the version 3.28 OpenGL API, but NVIDIA Quake II RTX mode with OpenGL compiler killed that performance completely. Average FPS 216.5 FPS. It took 22.8 seconds, and total frames 4,931 frame. Okay, now we're going to go ahead and switch it. We're going to custom width. We're going to do the 3840, and custom height we're going to do 2160. 4K resolution, 16 divided by 9 aspect ratio. Width, restart, enter. But of course lowercase, width underscore restart, enter. Now it's going to be 4K resolution completely. Here we go, and you can always check it, guys. Just go ahead and do our custom height and check out what we have, what kind of value we have. We have 2160, so our custom width, and it's going to show us that we have 3840. Okay, we got it in our system. So what I'm going to do now, I'm going to go ahead and run the benchmark. But before we're going to run the benchmark, let's real quick go ahead and enter our desktop screen, and I'm going to play a little bit with this guy right over here. We're going to do 1080p as well. I just want to see how well it's going to do the 1080p, shall we? Okay, let's back to it. And then we're going to switch to Quake II RTX, and hopefully I'm going to show you Quake II RTX through the RTX render as well. So we're going to play the demo command, demo map benchmark.dm2. Here we go, and we're rocking here, guys. Look at that crazy FPS. Wow. I think, okay, here we go. Average FPS at 4K resolution. Yamaha Quake II. 476.7 FPS, took 10.3 seconds to render, and total frame count is 4,931 frames. Okay, let's go ahead and do the custom height 1080. Just an extra bonus for those who's curious. I know some people will be curious. Go ahead and smash that like button. And 1920. Okay, with restored. And of course it's not going to work with the capitals. It did, but sometimes not all commands will work with the capitals. Keep that in mind. Okay, we got it. Now we're going to go ahead and demo benchmark. Let's go ahead and have a look. Oh, you know what, guys? That's low FPS somehow. Let me do the width restart with the lower caps. Somehow showing almost the same FPS as we did with the 4K resolution, and shouldn't be the case. That's strange. The FPS almost the same as 4K resolution. Let me real quick go ahead and pull up some data and see what our custom width is. Yeah, it's right. Maybe there is a cap in the Yamaha Quake II. It could be. It could be. Let me real quick go ahead and try to set it, because as you can see 5K resolution is available to us. Let me go ahead and try to set it 1920 by 1080. Or maybe I should click apply button. Let's go ahead and have a look, shall we? Nope, the same thing. That's strange. Maybe it's a cap. Let's maybe go ahead and click keep the resolution. Oh, keep the resolution. This is how on a 16K resolution render 1080p looks like. No, this is not what it is. Okay, one more thing, guys. One more thing. I'm going to real quick. Let me go ahead and switch the resolution. Let me do one more time 16K resolution. I just want to do it one more time. And custom width 15,360 pixels. Somehow it doesn't want to do it at 1080p. It doesn't show us correct FPS, and I think maybe it's a cap on the Yamachi Quake II. Custom height will be 8640. And what we're gonna do, let's go ahead and apply that. Keep the oh my god, I applied the 1080p, did I? No, we don't want to do that. Let's go ahead and switch to custom. Now it's going to be 16K resolution. I just want to do one more time 16K resolution test. Okay, and we want to do vid restart. Let's go ahead and do it. Vid restart. Okay, you can see it did it. By the way our overlay, it's different now. And let's go ahead and have a look, guys, shall we? By the overlay we can tell if it switched the resolution or not. And I don't think it switched at 1080p. I think it still was pulling 4K resolution. So this is the 16K resolution again, one more time, just to be exact, and then we're going to switch to Quake RTX, guys. Yeah, Yamachi Quake II was the fastest OpenGL API render for Quake II, but not the case any longer. Video with the same visuals pulling an extra 15-20%, and I'm going to demonstrate it to you guys in a second. Great FPS, great GPU utilization 97%, CPU utilization below 25%, as you saw. VRAM utilization, we still have some place to go to 8,000 megabytes. So we are utilizing 7441 megabytes of VRAM, 7.4 gigabytes. So average 79.5. All right, makes sense. Okay, we're going to be over with this guy. Okay, compared with this wallpaper, much faster PC, but now we're going to go ahead and execute the Quake II RTX. And of course it's set to RTX over here. Let me change that to OpenGL and change it to 16K resolution. Let's go ahead and have a look. Okay. So it's 24 Hertz. Let's go ahead and switch to 30 Hertz. Here we go, guys. Let's go ahead and run it, shall we? So, as again, time demo, space 1, same scenario. And instead of how to call the benchmark file of the demo that I was benching, instead of here, we don't need to type demo map. We gotta type demo space benchmark and without the dot dm2. Enter. And we got it. Look at this. At the FPS, you can immediately see that we have much faster rendering with this OpenGL API than we did in the Yamachi Quake II OpenGL version 3.2 API. So I'm not sure how NVIDIA did it, but they did it, guys. About 15-20% faster. Amazing performance. Look at the CPU usage, below 20%. Look at the GPU usage, 98%. Nothing is thermal throttling right now, guys. I think 90 something FPS average. Let's go ahead and have a look. 97.5 FPS average. 50.5 seconds to render it. Total frames 4,929 frames. Okay, good result, amazing. So now what we're gonna do, we're going to go ahead and switch to AK at 30 Hertz, which is also 16 divided by 9 aspect ratio of AK. Okay, and let's go ahead and as you can see, AF trilinear, texture filter trilinear, and AF 16x. So everything the same thing as on the Yamachi Quake II. Look how fast it is. This is the 8K resolution, guys. Yeah, that makes sense, guys, I guess. Look at the delay in milliseconds, below 5 milliseconds delay. This Quake II RTX OpenGL render, guys, is the fastest ever I saw at 16K resolution, and I tested on my i9 9900K and RTX 2080 Ti and SLI, or 4930K with the 4 Titan X Max GPU architecture. A lot of games at 16K resolution, and this is the fastest render ever I saw in any games. So, average 260.5 FPS, rendered in 18.9 seconds. Total frame was 4,929 frames. Okay, let's go ahead and switch to 4K. I'm going to do the 30 Hertz as well, so we're not going to desynchronize the video, because I'm not going to edit this video. I'm coming in real time, guys. Okay, 4K is going to be amazing, but the problem is we gotta lower it. Let's go ahead and do it like that, and let's get back to the game. Here we go. I'm predicting a lot of FPS, guys. Wow. As again, it doesn't matter 30 Hertz, 60 Hertz, or 120 Hertz. It's all about the testing today. It's all about raw performance in FPS. VSync is off, so Hertz on monitor doesn't give us any reflection in output of the raw FPS. Keep that in mind when the VSync is off. 1148.4 FPS average, 4.3 seconds to complete, and 4,929 frames. This is amazing result. And maybe let's go ahead and do 1080. Is it going to fake out 1080 over here? I'm just curious. or NVIDIA did a great job. 1080, guys. Wow, look at that. I just saw 3000. Oh my god, at 1 second. The average is 2123.7 FPS. It took 2.3 seconds to render the whole demo, which is like almost 4 minutes. The frames will 4,929 frames. Excellent. Now, guys, we're going to go ahead and do some RTX, some bonuses for you. RTX, I'm going to run completely maxed out, except the global illumination will be at low. We can make it off, which is no reason to run the RTX, or we can make it low. Let me go ahead and share it to you. Off, low, medium, high. I'm going to keep it at low, okay? And yeah, let's go ahead and do that. Let's go ahead and kick it. Let's go ahead and have a look if it's going to be playable. Nope, it's not. Sorry, boys and girls, it's not even playable. "13 FPS, wow. So it's going to be 13 FPS average, guys. Look, the GPU utilization 100%, guys. Look at that, below 10% on the CPU utilization. So this tells us that the future, and it's 1080p, the future is not the CPU core count when it comes to gaming CPUs. It's the highest frequency, and the 6 core is more than enough. Okay, the future will be utilized through a GPU, through a video card, and as you can see, CUDA cores is not fast enough to emulate the tensor cores that is basically used for the RTX technology. As you can see right now, it's kind of night, so during the morning you can add 2 FPS less, because it's going to be more shadows and stuff. So instead of 15 FPS, it's going to be 12, 13 FPS. Keep that in mind. Guys, as you can see, my benchmark is not only the performance, it's also demonstrating the visuals. So you can do the split screen. You can use my benchmark in Quake II Yamachi, Quake II RTX, Quake II XP, split the screen, and you're going to see through my benchmark. Just keep the right side of the benchmark and put the FPS stats over there. You're going to see, guys, that it's going to demonstrate you how well the technology between all of those different Quakes modes in terms of the graphics 3D rendering. The whole visuals and effects. Yeah, look at that milliseconds in delay. It's not ready. So pretty much CUDA cores emulating the tensor cores, and as you can see, CUDA cores is no longer a future, and AMD company is not even get to the level when they can match the CUDA cores technology by NVIDIA, and NVIDIA is not any longer says that CUDA cores is the future towards the gaming, PC gaming performance. It will be the tensor cores, guys, and with the tensor cores that's using for AI acceleration or deep learning acceleration, also can be used, as you can see, for the visuals, for the 3D game rendering. And guys, they can also emulate the CUDA cores. One tensor cores can be more than one CUDA core. I believe maybe like up to 2 or 5 CUDA cores in terms to be able to, for CUDA cores to emulate the tensor cores, and gives about the same performance, 1 to 5, I think, the ratio. So if you're going to reverse it, if you're going to render the whole DirectX API or OpenGL API, you just need to release the patch. Instead of CUDA cores, you're going to, or unified shaders, you're going to use the tensor cores. It's going to be amazing performance, guys, on the same video cards that's supporting the tensor cores. I see the performance up to 3-5 times more. Not 5 times, I mean 2-3 times more with the tensor cores versus the CUDA cores. So pretty much I'm running RTX 2080 Ti with the tensor cores here, and I'm receiving 30 FPS. Average at 4K resolution though, not 1080p but 4K resolution with the RTX enabled, and everything maxed out, global illumination set to high. In the end of this video, guys, I'm going to include this video for you to watch and to speculate and analyze. Go ahead and don't forget, guys, please, positive comments. As you can see, no marketing BS, no misinformation. Everything what I'm saying is value and can be compared to the performance to a regular average user. Sometimes I'm going extreme PC enthusiast, like 16K resolution and stuff, but it's nice to study on the level of the computer science, and my YouTube channel gives you a lot of value, guys. So don't forget to subscribe, smash that like button, and hit that bell when you're subscribing, and share it with your friends. A lot of goodies, guys. I'm going to teach you how to build the proper computers, how to waste less money, and how to have the highest performance possible per your buck. Look at that. Below 5% CPU utilization and 100% GPU utilization. This is amazing. And this is equal or faster than Titan X Maxwell GPU architecture right now, guys. And this is on a laptop. If it's going to be faster, maybe by a few FPS, by a little hair. But at least it's equal as Titan X Maxwell GPU architecture, which is the previous GPU architecture from the Pascal GPU architecture. So I would say 13 FPS average. Let's go ahead and have a look. It's almost there. The benchmark is almost over. It's going to tell us in a second. Beautiful lighting, as you can see over here. Beautiful scene. All right, so what is the FPS? Come on, show us. It's almost there, guys. It's a little pause in the benchmark, and it's going to be on any computer like that, unless it's going to run a crazy FPS, and you're not gonna feel it. And it's like about almost a minute of pause, just to show you, to cool down the temperatures a little bit, with repeating of the instructions on the GPU and CPU. All right, 13.2 FPS average, took 372.5 seconds to render, 4,929 frames. Okay, now we're going to go ahead and I cannot even imagine global illumination at high. It's probably going to be like 5 frames per second. So now we're going to go ahead and do the 720p. 720p. Here we go. Unfortunately, it's only, as you can see, at 60 hertz, but let's go ahead and take it. There is no 30 hertz for 720p. So the video might get desynchronized. I'm apologizing, but because I'm coming in real time, let's go ahead and have a look if it's going to be comfortable. Nope, it's not. But at least we got 30 FPS. At least it's playable. At least, guys, it's playable. So back to 1998, guys. Welcome back. CUDA course is just corn. It's nothing, as you can see. So the tensor cores is the future, and when the tensor cores utilized, the CPU utilization is the minimum. You don't need this multi-cores. You don't want to split 1% per each core. You're going to have that highest millisecond delay and latency, guys. Especially you want to have hyper threading when you're gaming, because the hyper threading give you the delay in latency, which is almost two times, I would say 1.5 times higher in latency delay when using the hyper threading cores versus the physical cores on your CPU. So this is why, guys, I shut down the hyper threading technology in my Core i9-9900K when I'm playing games, because I don't need it. Because it's yes, an extra core when you need it, but we don't need it with this low CPU utilization. When your CPU is not utilized up to 90%, you don't need an extra cores, guys. All what you need, the extra frequency, the extra popping frequency, this is all what you need. So you're going to pretty much compute these instructions faster with the higher frequencies. Because higher frequencies, higher impulsing, and higher impulsing reflecting in the higher instruction computing. time. So it's faster. Okay, well, it's playable. 30 FPS for some old school gamers that remember the Quake and 30 FPS at 720p, it's going to be playable. I remember at 1024 by 768 pixels at 60 FPS with my Voodoo 3 2000. Not the 60 FPS, I believe it was 90 FPS. In Quake 3 I got like 49, 50 FPS with Voodoo 3 2000. Here we go. I would say, guys, we're going to be averaging probably 31 FPS average. Let's go ahead and have a look. We decrease on our milliseconds delay, which is nice because in milliseconds delay, as you can see, 36 milliseconds delay, you want to keep it decreased as low as possible to have the comfortable gameplay. But FPS, you want to increase and have as much as possible for the comfortable gameplay. So we have what we have. 29 FPS average. Huh. Comfortable? No. Playable? Yes. So I find out the comfortable gameplay will be at this, guys. 800 by 600. This is going to be the comfortable gameplay. Let's go ahead and have a look, and we're going to go ahead and wrap up with this video. As again, it's not going to be about the visuals, it's just going to be about the performance. So as you can see, almost 60 FPS. Without the recording, we're probably going to be 55 FPS, at least 2 FPS higher. Decrease on milliseconds, below 20 milliseconds. So I call it comfortable, guys. Above 49 FPS, it's comfortable, especially in a game like Quake. Milliseconds is a little bit too high, but it's below 20 milliseconds. So when it's below 20 milliseconds, I call it comfortable gameplay, and FPS is above 49. Yeah, you can play it. 800 by 600. Welcome to 1998. The CUDA cores, absolute technology in 2019, guys. So the future will be no CUDA cores. Tensor cores is the future, and AMD cannot even match the CUDA cores NVIDIA performance. So if they're going to match the tensor cores, I don't know, but they don't have yet something like an Neuron core, something like for the AI boosting, AI acceleration, deep learning acceleration. And as you can see, it's up to 3 CUDA cores for 1 tensor core, I think, in terms of 3D rendering. And they're going to release a patch when even DirectX 9 and 11 and OpenGL will be rendered with the tensor cores instead of CUDA cores. It's going to be a great time, guys. Okay, you saw it, the average, you saw it as well, which is what? 52.7 FPS. Okay, that's it, guys. That's it. And I'm going to go ahead and quit it. Let me real quick go ahead and show you the hardware that we were using today, and we're going to be done. So my benchmark through the CPU Z version 1.87.064-bit version, the benchmark version is 17.01.64. As you can see, it's scored on single thread performance on this i7-7700HQ at stock frequencies at 346 points. Keep in mind that my i9-9900K with 2 cores disabled, hyper-threading technology disabled, and it's overclocked to 5.3 gigahertz per core with 6 core total, scoring 630 points, almost by 2 times. Unbelievable. And this is the very fast CPU, by the way, as well. It's acting as very fast i7, guys, because it's quad core, 8 threads. But as you can see, frequency is all about frequency. So the GPU information, as you can see, everything what you need to know. And right here, my GPU computing through the IDA64 and CPU computing of the i7-7700HQ. I'm going to put those screenshots for you to study, as well as I'm going to include the Quake II demo with instructions how to implement in Quake II RTX or Quake II Yamacha or whatever. Thank you guys so much for watching this video today. Look at how low the CPU utilization was. all the data was correct, valuable. Oh yeah, let me show you real quick before I will let you go. Let me show you real quick the item. Okay, so let me show you. This is the CPU support, just for you to study, for those who's curious. Great laptop, by the way. If you can purchase this laptop for $700 used with a dead battery, but if you want to convert this laptop as a desktop, ready to go, guys. Keep in mind that you want to repaste the thermal compound on a CPU for sure, and maybe on GPU. I'm going to use the Thermal Grizzly liquid metal, and it's going to lower my CPU and GPU temperature by about 5-10 Celsius extra, so maybe I can overclock my GPU and VRAM. Okay, you don't want to purchase the higher frequency VRAM DDR4, guys, for this laptop. Maybe you want to purchase, instead of 12 gigabyte that I'm having today, convert it to 16 gigabyte or 32 gigabyte, and you can render 3D. I'm doing a lot of 3D rendering to the 3ds Max on this laptop, no problems at all. I do YouTube video encoding up to 8K resolution, no problems at all. It's great, guys. So you don't need the AMD. AMD will be bankrupt, guys. Their 9th generation, third generation 3970X is nothing, guys. For that price, you can buy 4 Xeons from 2016, $60 per CPU. The whole computer will cost you about $450. You can build 4 Xeons, 8 cores, 16 threads, times 4, okay, but like used like new from eBay, and 4 computers will outperform 3970X by 2 times. I promise you that. Okay, so let me real quick go ahead and show you the GPU. So here we go, guys. This is our GPU. Keep in mind that it has level 1 texture cache, 24 gigabyte per multi-processor, and I think this is the big thing concern when we're talking about 16K resolution. That's why the Maxwell GPU architecture cannot run Construct Go at 12K or 16K resolution, and I think this is the big thing that's lacking. The level 2 and level 1 cache 2 megabytes on the Pascal GPU architecture today on this GTX 1070 video card, guys. And it's going to be the same scenario on any GTX 1080, GTX 1070, GP104, Pascal GPU architecture video cards, guys. And about the resolution real quick. So I'm going to test this laptop, Construct Go 16K resolution, to show you if it's possible to run Pascal at 16K resolution in Construct Go, but I know for sure Maxwell Titan X, 4 of them cannot run Construct Go at 16K resolution. But Turing GPU architecture, RTX 2080 Ti, in the Construct Go at 16K resolution, 133 megapixels, showing us almost 60 FPS average comfortably while I'm recording with the shadow play. Keep that in mind. And SLI, RTX 2080 Ti, showing above 110 FPS average. So, and I'm going to include this video in the end of this video. GPU, guys. So right here, it says the maximum 3D surface for the Pascal GPU architecture is 16,000 pixels by X, 16,000 pixels by Y, and 16,000 pixels by Z. That means that 16K resolution will be maximum possible resolution rendered for the 3D surface in OpenGL API and DirectX API for sure, and Vulkan as well for the Pascal GPU architecture. And I think this is the scenario for the Turing GPU architecture as well. And Maxwell GPU architecture, Titan X Maxwell GPU architecture, was running a lot of games, especially in 4-way, 4 video cards and SLI, Titan X Maxwell GPU architecture. A lot of old school games at 16K resolution, but it cannot run 16K resolution newer school games, and I think this level 1 and level 2 cache play a big role in that. All right, guys? So right now, guys, real quick, go ahead and show you the performance of this laptop. The orange will be 100% fan rotation on the AC. Today I was running this test on the AC, of course, connected to the outlet. And green color benchmark result will be the this laptop running stock, but fan rotation on auto. Real quick, guys, going through those details for you. Go ahead and check them out. It's a great laptop. If you don't have money, if you can buy it used for $700, go ahead, go for it, guys. You can play any games on this laptop. 1080p in 2018 at 60 FPS and above. Except the games such as that supporting RTX title, because you're going to emulate the RTX with the CUDA cores. Okay, this is the deal, guys. Right now I'm putting some cool videos for you to watch. Don't forget to smash that like button, subscribe, hit that bell, share it with your friends, positive comments, respect me, support me, and I will see you in the next videos. Check out those cool videos, guys. Peace.